Alright, so any questions on what to vec? I have still not covered a lot of things in what to vec, okay. So maybe go and read the paper for the details. Wait, one more thing. So remember we were making featured vectors. So let us say this is a 300 cross 1 word embedding learned using word2vec of whatever. Okay. Now, what do you think? What will be the first axis? What will be the second axis? So this is a 300 dimensional thing, right? So if this is a 300 dimensional thing, can you tell me what each axis is representing? Like, remember in the earlier videos, remember in the earlier lectures, we were trying to cover featured representation of words, right? So first one was maybe gender, second one was royalty and so on, right? So in this case my question is, what do you think? How do I interpret these numbers that I have got as 300 cross 1 vector? How do I interpret? So the answer to this is we can't really interpret. Okay. If you see that vector arithmetic that we had done that day, you rotate all these vectors keeping 0 at the center, right? They will still have the same relationships. So even though vectors, their absolute values, I mean their vectors will change, right? But the relative distance between all the vectors will still be the same, and hence even if you rotate them, it does. So the numbers there don't matter much. What matter is the relative distance between these vectors. Does it make sense? So if we want to understand that first axis is this, second axis is this, as of now we don't know how to do that. Okay. First axis could be, for example, a combination of alpha times gender plus beta times is fruit plus gamma times something. Okay. So we don't really try to assign any interpretability, we don't know how to do that. Other than that, what we have covered in classes is the skipgram model. Okay. Skipgram model was this. You have this center word, okay, and then you have a window of size C on both sides. Okay, that was your skipgram model. So they have also studied another model called CBOW, and that stands for what does CBOW stands for? Those who are doing NLP? Right, bag of words, right? So continuous bag of words. So what they say in this case, and in the same paper by the authors, right? So what they do in this case is, what were we doing in skipgram model? How were we making examples? This was, so how many examples will I make from here? Keeping center word fixed, I can make 2 C examples, right? If C is 2, then this will be 4. What continuous bag of word does is, you are given 2 C words of context and you are supposed to predict the center word. Okay. So how will you make your examples? Please give me a glass of water. How will you make examples in that case now? So let's say if this is my center word, window is 2, what will be my example? Right? So given these 4 words, I am supposed to predict glass. How will you make the neural network for this? The neural network is the same, except that you will have 1-hot vectors of all these 4. What does that mean? On your left hand side, instead of having just 1, you will have 4. At 4 places you will have 1s. Okay, and that's it. So skip-gram model is much more famous one than CBOW. It turns out it also works better than CBOW. Okay, so I didn't go to too much of CBOW. And anyway, this is not a course on NLP, so doing word to vec in that great detail doesn't really make much sense. So interpretability we have talked about this. I think this is more or less what I had to say about word to vec. Any questions here? Alright, then we start discussing GloVe. It stands for global vectors. And as we have talked about, word to vec unlocked a lot of ideas. So again, if you look for GloVe paper, you will get it. It is by not this one. So it is by Richard Schocher, Chris Manning and Jeffrey Pennington. Okay. So in this paper what they do is, so let me just make this particular table. So maybe try to make it with me. And you have to help me figure out how do I fill these numbers, even though you can't, but still, right? So these, let me first explain what is this. So this is the probability and ratio. So probability of word k given word ice, probability of word k given steam, and then this is the ratio. So let's focus on just these two, primarily on this one. So randomly, this question is, what is the probability of solid given ice? Yes, so you have to tell me this, good I mean high, okayish or low, right? So let's keep it high for the time being. What about probability of gas given ice? See, ice is solid, but ice is also a form of water, gas is also a form of water, right? So what do you think? Whatever. What about water? So when K is water, what is probability of water given ice? And what is the probability of fashion given ice? Right. So first of all, tell me, nobody asked me how are we computing these probabilities? What do we mean by probability of solid given ice? That's true, very good, right? So again you are having a corpus of size, let's say 1 billion, okay, and then you see again in the context, see Word2Vec started this context thing and is still prevalent, okay. So I mean they were not the first one to start this, but that was the major breakthrough. So probability of ice, probability of solid in the, so again the probability of solid occurring in the context of ice is pretty good, okay, and so on for all these other numbers. So for their corpus, and will it depend on corpus? Will it also depend on corpus? Yes. So a small corpus is good or a huge corpus is good? What may be the properties of a very big corpus? So let's say if I just take blogs on movies, right? Will it be a good place to look for this relationship? Right? So in general you can't really focus on one kind of a text, right? It has to be as heterogeneous as you can have it. So for their corpus these numbers were 1.9 into 10 to the power minus 4. Is this high? This is 6.6 into 10 to the power minus 5. This is 3 into 10 to the power minus 3, and this is 1.7 into 10 to the power minus 5. Okay. Now I am filling the next row as well. So this is 2.2 into 10 to the power minus 5. All right. What are these numbers? What are these numbers? Is this a high probability? Is this a high probability? It is. See, you have potentially hundreds of thousands of words in your corpus, right? So this is actually a high probability because there will be words with probability of the order of 10 to the power minus 9, minus 8, minus 10. So there it is 4 to 5 orders of magnitude higher, okay. So this is indeed a high probability because if you see in the context of ice there are so many possible other words as well. Solid is just one of them, right? So it can't take probability of something and 0.8. That means you have just one line in your corpus maybe. And similarly this. So what we observe from this table, probability of solid given ice is relatively higher. Probability of water given ice is even higher. But do we expect that? If we take a large enough corpus, do we expect that the probability of water given ice will be good one, right? So, but what about this one? What do you think? Probability of solid given ice, is it okay if this is lower than this one? So this is just from their corpus, right? We don't have to take this too seriously. Why 1.9 into 10 to the power minus 4? You change corpus and these numbers will change, okay? So what is important, and similarly for this, probability of K given steam. Now steam is the gaseous form of water, so it doesn't occur that much with solid, but if you see, steam is the gaseous form of water, and now if you see these two numbers, they are kind of interchanged. Ice with solid was higher, of the order of 10 to the power minus 4, but with steam, gas is, right. So if you see, there is this cross thing, but both are related to water. So both ice and steam, they are related to water, so roughly similar probabilities. And what about this one? They both are roughly equally unrelated, right? So these numbers. So these numbers absolutely, they don't make much sense, they depend just too much on corpus and so on. So what authors say is that these numbers, don't take them too seriously, but what we should talk about is actually this ratio. So for this ratio, they say it is 8.9. So now let's have a look at this particular ratio. And what is this telling me? So let's say, what are these two ratios telling me? They are equally. So when a ratio is closer to 1, what does that mean? So they are either equally related or equally unrelated, right? What about these two guys? A number much greater than 1 and a number much lesser than 1. What do they imply? Some kind of relationship, right? It can be occurring in that context or it can be not occurring in that context, okay? So this is the table they motivate in the paper, in the GloVe paper, okay? And what GloVe does is, so why are these called global vectors? So let me just write the cost function for GloVe, and then, so the major result for this paper was cost function. Remember cost function from word to vec? What was that? Summation over all the center words, then summation over all the context words. You have to find the log probability of context given center, right? So that was too complicated. Now in this case, if you see, initially it will look complicated, but so let me just, or maybe I will do that later. Right. What is this cost function? And this is much simpler than This is much simpler than word to vec. Why so? So let's try to figure out. Now by now you can tell me where are the parameters. Can you tell me where are the parameters? So W's and B's, these are my parameters. Okay. What is this term? So Xij I have to get from somewhere. Now f of Xij is a very simple function, I will tell later. So does it look simple now? Have you seen this kind of thing before? We have seen this kind of thing before. Doesn't it resemble the mean squared error? There you had something y minus y hat whole square, right? So something of that sort, because this is also a squared function. Now the only thing that we don't understand here right now properly is Xij. Okay. So how do we do that? What is Xij? So let's try to see what is Xij. So I'll come back to this equation. Xij is basically, it's a matrix. Okay, it is called co-occurrence matrix. Double R? No. Let me see if the spelling is right, or double R will be there. Double R. So co-occurrence matrix. Okay. Remember, how did we get each training example from word to vec? This is in sharp contrast with that, but is related to that idea. So what happened in word to vec? For every training pair, it was a local pair. What does local pair mean? See, water was appearing in the context of glass. We actually took one such example and trained on it. But in my corpus of, let's say, 1 billion words, 100 billion words, will water appear a lot of times in the context of glass? Is that true? So what will word to vec do? Word to vec will have glass, comma, water, a lot of such examples, right? Because it looks at that particular word locally. So right now it is at this word, look at plus minus 2 words, go to next word, look at plus minus 2 words. So let's say this appears twice. So when it appears once, you've trained on it. When it appeared on the second time, what will you do? You'll still train on it, right? So they are appearing at different places, because if you look at that particular cost function, it does not differentiate between where is it occurring, right? It simply says do it for all words from 1 to capital T, look at the context and try to figure out the probabilities. What GloVe does is, it tries to take the global properties of the corpus. So what could be the global properties of the corpus? That Xij. Okay, so let's try to see what is this Xij now. It is called co-occurrence matrix, and let's see what is this. So again, our example is so our corpus is still please give me a glass of water. Now, what will be the size of this Xij? So, let me take, this is my first word, this is my second, and for the time being I am not counting dot as a token or a word. Okay, so we are keeping things simple for us. Now, these are my columns, and what will be my rows? Same, very good. So, rows will be the same. I have 1, 2, 3, 4, 5, 6, 7. And now how will I fill these words? Please in the context of please. Okay, what should I write here? 0. Can I make this diagonal 0? No? So give me a word that appears in its own context. There will be words, right? But we just ignore them. For example, the might occur in the context of the because it appeared at two places, right? In my, so the higher the better, right? So now the will appear in the context of the itself. Okay. So let us try to make this diagonal 0. We don't want a word in its own context. What else? What will be please comma give? Actually it's a bad example because all are distinct words. Please give me a glass of water. Please. Okay. I don't want to make a bigger because otherwise my matrix size will be huge. Okay. So we don't have it actually 7, we have 8 now. Right. So I will have a 0 here as well. And this is not looking like a square matrix, but it is. So this is how much? 8 cross 8. Now, so I don't like this example. यार कुछ तो ढंग का example दो. Give me a couple of sentences that so that same old example, I like NLP, I like deep learning. So we have 7 again. Huh? अब ठीक है, कितनी बार मिटवाओगे यार? So you do on this example. Okay? So so nobody appears in the context of itself. I like, right? So how many times does I like? So this you will have 1 here. Okay? I NLP 1, why 1? Context window size is 2, that's what we are assuming. So 1. I in the context of I? No, because we are just taking context window size of 2 and so on. So this is done. Now once like is there, so I will have just 7 here. Yes. Yes. So context window is 2, I 0, this one, then I again 0 here, and then rest of these guys will be 0. I am making some mistake here, है ना? हाँ? Right. So let's. I am making some mistake here. So hopefully I'll remember it before I finish. So what will happen again here? This is I. So will it be symmetric now? Yes. Will it be symmetric? Yes. Like in the context of like, no. Like in the context of NLP, will I have one here? Yes. Like in the context of I? Yes. And so on? No, I am making some mistake here. Yes, so let us try to come there. So NLP, so will it be symmetric? Yes. 0, 0, 0. What about when NLP is the center word? This 0 is gone there. So zero, and then what about here? NLP in the context of I. Okay, what next? And this is 1, 1, 0, 0. What next? I will have a 0 here. Then I again have I. So NLP is gone, third. Okay, what about I again? In the context of like, in the context of NLP, in this context. Yes, मैं गड़बड़ कर रहा हूँ ये, but हाँ? Thank you so much. Thank you so much. Thank you so much. So, of course, this won't. So, it was so stupid of me to take this one. Why? Why? Because see, for a 1 billion corpus size, this will be a 1 billion cross 1 billion matrix, and you don't want that, of course. So thank you so much. Now since we have this as our corpus, what I should do is erase everything. right? So this will not be a 7 cross 7 matrix, it will be rather a, so how many different words? 5. I am calling this 1, 2, 3, 4, 5. So this is 4 and this is 5. So this is a 5 cross 5 matrix, and in general it will be a V cross V matrix. Okay. Now, so I appears in the context, now it's much better. Yes. Now I appears in the context of like, so let me first put all these guys as zeros. Now I appears in the context of like 1 in the context of NLP, 1, 0 and 0. So 1, 2, 3, 4, 5. 1, 2, 4, 5. Now this is fine. So once I come there, we'll do that. Okay, I'll update this one, or you can do it this way, that look at all the pairs at once. Okay, so now like what happens? I mean, see what we are saying, we can do this because it's a very small corpus, I can just look at and figure out. But in general, you will have to look at the whole corpus to figure out how many pairs are there. Okay, so all we are doing here is that same word to vec thing. In word to vec thing, what are appearing in the context of glass? The only thing we are looking here is how many times do they appear together. That's it. And it is symmetric. So glass comma water will be symmetric as water comma glass. Okay. So this is fine. Now second, jaldi batao bhai. 1, 1, 0, 0. What next? Like NLP. Like, right? So now what should I do? I should make this 2. Okay. If this becomes 2, then this will also become 2. Why is this symmetric? Because we are saying center word and both sides see context. If you take both sides different context, or if you say I will take context only as the previous words or only as the later words, in that case, will this matrix be symmetric? It won't be. Okay. Now quickly बढ़ा दो यार ये. So like in the context of I we have done. For the time being 0, 0, because otherwise this will also change, right? Now third one, we go to NLP. NLP comes in the context of like. This guy remains 0. What happens here? Or 2, 2, 2, 2. What next? Arey yaar. Thank you. Yes. This guy will be 0, 0. What next? Fourth is deep. Like. So deep and I. So will it be 1 here? 1 here, and then deep ke context mein I also have like 1 here. What else? I don't have NLP. 1, and then this guy will be 0. Is that right? What will be the next one?
Sir, अगर 1, 2 और 1, 3, 2 है तो 1.
Just give me the final matrix here. What will be the final matrix? So in the context of learning, I will have just like and deep. So like and deep and 0, and I need to make this symmetric. So this one comes here. Anything else? These two have to be made symmetric, so these guys will not be. Is that right? Is that right? Right? So it will be a V cross V mod V matrix and not corpus cross bus. Anything wrong? Here? So just tell me and I'll make that. ये भी बन हो जाएगा? And? Okay. Right. So this is a symmetric matrix. That means if I occurs in the context of J, so these I and J, what are these? These are the words, index over the words. So now let us go back. So now you know how to compute Xij? I mean, okay, so this is not Xij, this is matrix X, and Xij is the each element. Okay. So what will be Xij for I equal to I and like equal to J? 2, right? And that is also, so I comma like is 2, like comma I is 2, because this matrix is symmetric. So what is this matrix capturing actually? What was word2vec doing? So my whole purpose of doing this matrix was just this. What was word2vec doing? It was doing things locally. At every pair you will train multiple times. You will train as many times as it will occur in your context, that context target pair. Okay. In this case, what are you doing? You are making global level statistics. If this were like 1 billion size corpus, then these numbers will be much higher, right? So what does it mean to say that a number is much higher? Those two words appear in the context of each other a lot of times, and those that don't occur, they also tell you something. Those that occur tell you one kind of information, those that don't occur tell you another kind of information, right? So these numbers carry a lot of information about those two words, right? And this is what GloVe tries to exploit. Now come here. You know Xij? Is computing Xij computationally intensive? सोचना एक बार. See, word2vec was tedious until you do negative sampling. So is computing Xij a very expensive task? So let's say your mod V is 100k, which is a moderate one or maybe smaller one. What will be the size of this matrix? 100k cross 100k having 10 billion entries. But let's say it is 1 million. So 1 million cross 1 million having 1 trillion entries. But you will compute it only once, right? Your corpus does not change every day. So you are going to compute this only once, and hence it is okay to have that. Once you have all these Xij's, tell me what will this cost function do? So when I equal to basically mod V, so I'll simply put it this way now. You have two summations j equal to 1 to mod V, I equal to 1 to mod V, right? Is this equation making more sense now? Guys, एक बार जल्दी से देखो, मेरे को आज ग्लोव खत्म करना है. Is this equation making more sense now? See, you understand what is Xij? These are my parameters. I'll still keep them as you have to figure out, because they are coming from word2vec type of kind of things, right? So I'm not going to explain this too much to you. What is this whole thing? Why do you need this? You need this if Xij is 0. See, for a lot of, is this matrix sparse? There will be a lot of zeros there, right? Even if you can't call it sparse, but there will be a lot of zeros there. So it will occur a lot of times that xij is 0. All this f of xij does is, f of xij is 0 when xij is 0. So no matter what comes here, that becomes 0. So for xij that does not appear, this term is 0. Is that what we want? For all xij's that appear together, you train. This is something you know from your corpus. So doesn't this look like y minus y hat kind of thing? So what are you trying to predict in this case? These are my parameters. I am trying to get them closer to xij. When I will minimize this j, what is essentially happening? Tell me. This function is now clear. This is summation over all the pairs. So how many, all xij's are covered there. Okay. These are my parameters. This is a mean squared error kind of function. You are trying to set these parameters such that you get these global xij's, right? So y minus y hat kind of thing, this is your y hat, this is your actual label, and then this looks similar to the mean squared error. In fact, it is actually mean squared error. Okay, so in that sense this cost function is much more simpler compared to Word2Vec. Now why simpler? Because there it was a very complicated one, not concave function. In this case this is a convex function, right, having only one global minima. So that makes training much better, right? So it is simple in that sense, not the way it looks. I have still kept this one cryptic for you, so you are still supposed to give me what is the neural network that this is trained on. And I will not cover that in classes, but it is part of the exam. So this is a homework that may be part of the exam. Maybe. I am not saying it will be. But this should give you hints. This thing should give you hints already. Astha, Adhiraj, Akshat, Amit is not here, Arohi, Arukshita, Ashmit, Disha, Divyanshu, Ishan, Garv, Himanshu, Kanishk, Kashish, Keshav, Kushagra, Melissa, Muskan, Nilesh, Niharika, Paras, Payal, Rani, Ridhika, Riya, Riya Singh, Saurabh, both Saurabhs, okay, Srishti, Shreyansh, Siddhi, Saurabh, Swastik, Vaibhav, Vrinda, Yash, Abhinav, Archita, Nitin. Chalo, thank you. कौन सी वाली?